Welcome to our presentation on international environmental agreements. So this is our outline. First, me, Francisco, I'm going to recapitulate Barrett's paper. Afterwards, Maria
Morning.
is going to introduce us to the finished paper. Afterwards, Jana is going through the key findings from the same paper.
Hello, I'm here too.
And also, Will is going to present us and do some analysis on the Paris Climate Agreement, and to wrap it up, some discussion.
Hi.
So, let's go into the self-enforcing international environmental agreements from Barrett's 1994. So, countries can be either signatories or non-signatories, being signatories the ones that are inside the coalition. So, these countries maximize their utility, and coalitions maximize their joint utility of all member states. It's also important to note that countries are identical in all respects. This is homogeneity. So the decision that countries made in this paper is twofold. First, they decide to be either a member of a coalition or not, and afterwards they decide what's the abatement quantity that they will make. To solve this decision, we use backward inductions. So this is the country's welfare function. It's very simple. The global abatement benefits minus the individual abatement costs. And as said before, coalitions take into account the joint utility welfare of all their member states. So it's just the sum of the country's welfare. So it's very important to note that benefits are linear to the abatement quantities, the global abatement quantities, while the costs are quadratic to the abatement quantities of each individual country. This will have implications later on the size restrictions of coalitions. So let's start by using backward reduction on the second stage. So this is how much abatement each country will do. So maximizing the welfare function of a country, we reach that a non-signatory country will do omega divided by C abatement quantity. This is a dominant strategy because it does not depend on the abatement quantity decided by any other country or the global abatement quantity. Regarding the coalition members, their abatement quantity is n times omega divided by C. This multiplication by n is due to the taking into account the utility of all other member states of the coalition. Naturally, the coalition as a whole will just do n times the quantity abatement of each member state. By looking at this, we can conclude that being a non-signatory is strictly better than being a signatory. This is because signatories have a higher abatement quantity, and because regardless of being a signatory or a non-signatory, countries benefit from the same global abatement quantity while having their own individual abatement quantities costs. This is so coalition members have higher abatement costs. So now let's solve the first stage. This is if the country joins a coalition or not. Coalition is stable if internal stability and external stability holds. Internal stability is when no member country wants to leave the coalition. This is when the utility of being a member state is higher than not being, while the external stability is with no outsider want to join the coalition. So the utility of not being in the coalition, a non-signatory, is higher than being a signatory. So wrapping it, a coalition is stable when the number of member states does not change. So by doing the maximizations and the math, we reach the conclusion that external stability, this is all with less than 3. This is no outside country will want to join any coalition that is 3 or larger. While internal stability leads us to the conclusion that coalitions with more than 3 members are not stable, so some countries will leave until it's just 3 coalition members inside. So this is due to benefits of joining a coalition and costs of leaving the coalition increasing linearly to n because they are linear to q, and the cost of joining the coalition and the benefits of leaving the coalition increase quadratically to n. So to wrap it up, the coalitions are stable when n equal to 3, assuming that the countries are all homogeneous. Countries have an incentive to free ride on the global abatement costs, and they would rather not join the coalition. But if no other country is joining it, they are better off by joining the coalition than just free riding on a global abatement with a coalition of 2 members. And also, countries do not see as adventurous being on a coalition of larger than 3 because by taking into account the more than 3 countries, the abatement costs are larger than the benefits that they get from the larger abatement quantity. Also, cooperation, reach the conclusion that cooperation is more important when there is larger quantities of countries in the world. So, the Finnish papers takes into account this theoretical framework and introduces country heterogeneity and the possibility for multiple coalitions. This means that countries with different characteristics and different interests will be able to join their own coalitions and leave the other countries to their own coalitions as well. This will have some interesting applications that my rest of the colleagues will explain.
Okay, so now I'm going to take over the paper by Finus, and this paper reports on some recent results that should demonstrate the usefulness but also the limitation of game theory for the analysis of international environmental agreements by looking at different designs and success of these agreements. The results are illustrated for the climate change problem with empirical stability of coalitions model. So one may ask, why should we use game theory to analyze the formation and stability of international environmental agreements? Well, the first reason is due to their international dimension and the increasing coverage in politics, media, and the public. All of this makes coordinated action at global scale necessary, and also especially because the progress has been recently slow. The main reason for that is free riding, which is the most important obstacle for successful IEAs. That's why it is important to understand the strategic considerations of the actors causing environmental externalities. On the other hand, game theory is a mathematical method that studies the interaction between agents based on behavioral assumptions and makes predictions about the outcome of these interactions. And even though global rationality would call for cooperation, individual rationality often stipulates free-riding behavior since there is no supranational institution that can enforce participation in IEA and their compliance. So the theory of coalition models. Well, up to now there is no coalition model that captures all aspects of coalition formation, which includes institutional details of treaties, such as instruments of implementation like emission taxes or permits. Then political aspects of negotiation, such as interventions of interest groups in favor or against the agreement. And finally, the fundamentals of the game theoretic analysis of international environmental agreements. And following the last point, there are two types of free riders. The first type refers to the incentive not to participate in an agreement, and the second one refers to the incentive not to comply with the obligations agreed. Membership models focus on the first type of free rider incentive, and they assume that once a country joins an agreement, it will comply with the agreed treaty obligations. On the other hand, compliance models concentrate on the second type of free rider incentive, and they test whether treaty obligations can be enforced with credible threats to sanction non-compliance. Membership models can be divided into cooperative and non-cooperative. Cooperative, in contrast to non-cooperative game theory, assumes a third party that can enforce an agreement. For that reason, cooperative game theory models could not be suited to analyze the problems of cooperation in international pollution control. Both of them assume full compliance with abatement obligations once a coalition has been formed. So the question is why the non-cooperative approach is superior. Well, there are three reasons. The first one is the fact of missing supranational authority and also that countries behave as individual optimization. However, the latter does not imply that countries are not interested in cooperation, and besides, ethical and moral reasons can be considered as part of individuals' objective functions. The second reason is that it is also considered more general and more transparent in terms of assumptions, which allows replicating assumptions from the cooperative approach. And the last reason is its potential for explaining real-world phenomena of IAs is much higher for the non-cooperative than for the cooperative approach. So by definition, in the context of externalities, only the grand coalition, that is, the coalition of all countries, implementing the socially optimal abatement target can be stable. What is more important and controversial is to identify problems that prevent full cooperation and measures to overcome these problems. So here we have this structure of non-cooperative membership models, and these models are divided into two stages. In the first stage, countries decide upon their participation, and that decision leads to a coalition structure that is stable if no country has an incentive to revise its participation decision. Secondly, countries decide upon abatement and possible transfers. So now going through the base model, which assumes that there is only one single agreement, it's of course divided into two stages. In the first stage, countries simultaneously decide whether to join an international environmental agreement, and moreover, the base model assumes that there is only a single agreement where those countries that do not join the agreement remain non-signatories and other countries are signatories. Moreover, the membership is open, which means that no country can be denied the access to the agreement. Secondly, once a coalition has been formed, countries decide simultaneously their agreement levels, which is known as Cournot assumption. So coalition members choose their agreement as to maximize the aggregate payoff to their coalition, and every non-member maximizes its own payoff. This means that coalition members internalize all externalities within their coalition, so abatement is efficient within their coalition, but they ignore the externalities imposed on non-signatories. Specifically, the coalition abatement level is optimal for the coalition, and the allocation among its members is cost-effective. However, costs and benefits of abatement are likely to be heterogeneous across countries. So for this assumption, if the grand coalition were to form, it would implement socially optimal abatement levels, but if no coalition formed, this would correspond to non-cooperative abatement levels, also frequently called Nash equilibrium. And just to mention, the base model assumes no transfers to correct for a possible asymmetric welfare distribution, and also the abatement decision is taken by social planners of individual countries by looking at costs and benefits from abatement, so based on material payoffs. Finally, this table summarizes the structure of memberships models. The left column shows the assumptions of the base model that I just explained, and the right column includes possible alternatives and extensions of the base model, for instance, including sequential decision rather than simultaneous, multiple and exclusive membership instead of single and open. And regarding unanimity versus majority, the results suggest that allowing for multiple coalitions with an unanimity voting, the success of cooperation improves. So now John is going through the main results.
Okay, thank you, Maria. Now I'm going to take over and talk about results from Steco model with which restricts emissions path to be constant over time. Specifically, at various coalition structures with their global abatement and global welfare over 100-year period. By looking only at single agreement, we see large potential gain from cooperation. Global welfare in global optimum is 3 times larger than in Nash equilibria. This potential clearly demonstrates importance of number of members in coalition. Further, looking at coalition of energy exporting countries and China, we see that it leads to a higher global welfare compared to a coalition between former Soviet Union countries, Brazil, and the rest of the world. What implies that not only number but also identity of membership is important. This is linked to 2 points. First, countries with a flat marginal abatement cost curves, like China or India, are already producing in dirty ways and thus it's cheap for them to reduce greenhouse gas emissions. And at the same time, US has opportunities for energy saving and substitution at low cost. Second, countries with high marginal benefits from global abatement, such as EU15, United States, and Japan, push for high coalition abatement in a given coalition, from which not only coalition members but also outsiders benefit. Let's now look at open membership versus exclusive membership design in single agreement, hence where only a single coalition can be formed. Under open membership, players are free to join any coalition, and under exclusive membership, this is only possible if majority or all are in favor of accession, ai it raises the members' payoffs. We have already seen potential for gains, now we are going to introduce stability and see best coalition for each design. First, under the base assumption, there is no stable coalition. But when we switch from open membership to exclusive membership, we see that coalition of FSU, Brazil, and the rest of the world is now stable and also leading to higher global welfare. But when we move even further from majority voting within exclusive membership to anonymity voting within exclusive membership, we see that 2 other coalitions are stable, and the best coalition of these with the highest global welfare is coalition of EEX in China. But we still could go further, and now going from single to multiple agreements, when we allow for these multiple coalitions, open membership has still no stable coalition, as well as exclusive membership with majority voting, leaving us in both scenarios with singleton structure. But when we allow for multiple coalition with anonymity voting, success of cooperation improves even more, from 2.2 thousands in single agreement to almost 2.5 in multiple agreement. Hence, in the absence of transfers and efficient allocation, some members are even worse off than without cooperation. China, for instance, as a member of coalition, has to contribute much to the joint abatement level because of her flat marginal abatement cost curve, but benefits only little. On the contrary, the EU15 contributes little to joint abatement because of her steep marginal abatement cost curve, but benefits much more because of high marginal benefits in this case. Therefore, only coalition structures comprised of members with a similar cost-benefit structure can be stable. Otherwise, disadvantaged members leave and internal stability of coalition is violated, or advantaged countries have an incentive to join and hence external stability is violated. It is exclusive membership that can make difference, and besides, anonymity makes it easier than majority to keep advantaged countries out. This is the reason why, regardless of treaty design, no stable coalition with major industrialized regions and non-industrialized regions can be stable. A single agreement has a strong free ride incentive, and decision is in this case often no, and only small and few coalitions could be stable. Multiple agreements, on the other hand, allowing for additional options, forming another agreement with like-minded countries are much more beneficial and stable. Now we are going to look at the role of transfers, keeping other base assumptions constant and considering only monetary transfers within a coalition. We are going to compare two types of transfer scheme. At first, it's pragmatic transfers, which preserve status quo, and second, it's transfers which are linked to some notion of equity. From the table on the slide, we see that both pragmatic schemes are better than morally motivated transfer schemes. In addition, only for the pragmatic schemes a stable coalition emerged, including industrials and non-industrials regions. From this, we could draw two conclusions. The transfers are important to balance asymmetries and can improve upon the success of cooperation. And second, the successful cooperation requires participation of industrials as well as non-industrials regions, what leads to mixed membership, which could be achieved with moderate transfers, which take into account the fundamental interests of all actors in climate change. Here, we compare equal design to three alternative treaty designs regarding emission reduction quotas. When not considering stability, large global welfare loss could occur, especially for large coalitions. But when we consider stability, there is no coalition stable under equal design. Let's look at it more details at this table. And we see that the highest average global welfare is obtained from lowest quota proposal, followed by median quota proposal, and then the common quota for both with and without trading scenario. This leads to two beneficial improvements of trading. First, it is less attractive to leave a coalition, and internal stability is strengthened in this case. And other benefit is that external stability is weakened, what means that it's more attractive for outsiders to join a coalition. Conclusion in the second best word is that in absence of such transfers, there is a rationale for implementing uniform emissions reduction quotas, and also there is a pressure for consensus treaties, and it's not always an obstacle for successful cooperation. Now I would like to pass my word to Will.
So this section we're going to produce a quick review of the Paris Agreement. So firstly, I want you to have a think about whether it's been a success, whether you're not sure if it's been a successful failure or whether it has been a failure. So feel free to pause here and I'm going to keep going on. So here we produced just these few bullet points summarizing what has been agreed. So it was it's implemented in 2016 and would only be implemented once 55 countries accounting for 55% of global emissions have completed all the necessary steps. Key points from the bullets are the target is to limit the global temperature increase to well below 2 degrees and keep in mind the 1.5 degree target. The NDCs, which are each country's commitments on emissions reductions, are to be updated every 5 years. No backsliding is allowed. And also of note is that support will be provided to developing countries from developed, but there's no obligation to do this. So here we're looking at those NDCs in more detail. So these are two historical emitters, and the next slide you'll see two more current emitters. So I provided quite a lot of detail here so you can look over it yourself. But the key points to take out are China are a bit of a problem, so they are funding a lot of coal power stations. They're a large consumer of coal. They're even funding coal-fired power stations abroad. And lastly, I've included Saudi Arabia at the bottom just to show how the NDCs can differ substantially between countries. So their reduction of 130 million tons of CO2 is very small, and if we would look in the following slides and see that they've essentially done nothing. So here we're looking over the reduction due to the Paris Climate Agreement with the counterfactual of no Paris Climate Agreement, and we see that there has been a reduction in greenhouse gas emissions. But then we change the slide and we can see that the scale of the challenge is not being met anywhere near. So we looked at we're not meeting the needs of climate change and how to act against it. Here we can see which countries are at fault for that. So only 2 countries are in line with the Paris Climate Agreement, which are Morocco and Gambia. So to provide further information on how they're doing so well, so they're investing both massively in solar. So for example, Morocco have solar farms spanning the size of 3,500 football fields. So next slide, we're looking at tying back the Venus paper to the Paris Agreement and whether the Paris Agreement can learn anything from this. So the Paris Agreement is a global coalition. There are many countries involved, but the method that Venus said would cut emissions the most, However, that was conditional on abatement targets being at the social optimum, which is definitely not the case for the Paris Agreement. Voting is unanimous on how the agreement was structured to begin with, but the NDCs are country determined, therefore it's not really in line. And Venus talked about transfers as if he was talking about a permit system, which is not the case with Paris. Some of the largest emitters are the ones with the lowest emission reduction targets. And then finally, if we compare abatements, Venus predicts an abatement of 7 to 9% over a 100-year period. Paris probably would be in line with this, but 7 to 9% abatement would lead to catastrophic consequences. So quite topical is that the US withdrawal is coming up in November. Just want you to think about whether it will help, whether it will have no impact, or whether it will be damaging to the agreement. So here are a few experts' views on whether it will help or not. So of course the overall target will not change. The Paris Agreement is unlikely to fall apart because the US leaves. However, it's possible this could actually help the Paris Agreement. We can see that from the small target emissions reductions that the US has and whether this possibly hinders other countries setting more ambitious targets. On the other side of the coin, they are now a free rider, and free riding usually leads to more free riding, and so this could obviously be an issue with future NDCs. And finally, Trump has cut spending dramatically in climate change research and development. Could this hold up innovation of new carbon capture methods, for example? So here we look at how the NDCs will be updated, which are due to be updated towards the end of this year. So we can see if the US and other factors have had an effect on this matter. So firstly, although many countries said they will enhance their ambition, they account for such a little amount of the global for the greenhouse gas emissions. In addition, 36 parties only intend to update their NDCs, EU and India included in this. However, the biggest issue here are the countries that have not signalled an intention at all. That includes Russia, China. It accounts for 70% of the global greenhouse gas emissions. So finally, at the start I asked if Paris was a success, failure, or you're not sure. Hopefully you have a clear idea now. Some experts would argue that it's returned the possibility of reducing emissions in the future to hit the 1.5 or 2 degree target, whilst others say that it's been watered down to such an extent by developed countries that it's become a failure.
Thank you, Will. So now, to wrap everything up, we can see that exclusive membership and unanimous voting are superior to open membership and majority voting within coalitions because they allow for a better utility for its member states, as countries with different characteristics will align themselves with other countries, like-minded countries and similar countries. This also allows it that multiple coalitions exist is superior because this will facilitate the countries to choose their coalition that fits them. Also, looking at Paris, it's still hard to determine what success it will have, as we are still very close to its beginning. However, the next 5 years will be very important for this analysis. So with this, we end our presentation. Thank you very much for your attention.